Hey everyone, welcome back to PrepFusion. I'm Anish and today we'll be starting the lecture 7B of frequency domain analysis, right? So in the previous lecture we did few questions, right? I introduced overlooked zeros and we tried to plot the polar plot for that OLTF. So I couldn't complete all the questions that I had, right? So in this lecture I will try to complete the remaining questions as we are constrained with time, right? So in this lecture we are going to do, we are going to plot the polar plot of OLTF for a non-minimum phase system, right? When my phase is non-minimum. So like you see these two, right? I hope you can plot it by yourself also. So this is not like I will tell you something new. Few things I will tell new, right? But most of the things by with your aptitude and whatever you have learned till now, you can solve it for yourself, right? So yeah, let's start basically. So let me plot this first OLTF. You try to plot it for yourself, right? So first what we'll do, obviously put s equals to j omega. Like those steps are same. Like for polar plot, right? Most of the steps are same only. Okay. So like if I put s equals to j omega, this becomes minus omega square, and this becomes j omega minus 2. Now what does non-minimum phase system mean? Basically it means, right, my poles will lie on the not all, few pole or zeros will lie on the right half of my s plane. So in this case, right, here I have a pole at s equals to 2, so it is lying on the right half plane of the s plane. So in which quadrant is it lying? Like I hope you remember, right? We have to find the angle. For that we have to find in which quadrant this is lying. Okay, but first let us find the magnitude, because that will remain same for non-minimum phase system or minimum phase system. So it is same only. Ten omega square plus 4, right? Omega square plus 4. Okay, so this is what like the magnitude function is, right? So now let's write the expression for the phase basically. Okay, just hold on a second, let me see if it is recording or not. Yeah, this is recording. Let's see the expression for the phase basically. So for phase, right, angle of g of g omega h of g omega equals to, so like for phase, so this, right, this is two poles at the origin, type 2, hence it will provide a minus 180 degree angle, that we already know, right? Or from here you can understand, right? From here also you can understand. So this will provide a minus 180 degree angle. Okay, now what about this one? So in which quadrant is this line? So if I like draw the coordinate axis, right, this is sigma, this is j omega. Okay, so what I can say is, like, this is always positive, right? So omega is always positive, so it is lying somewhere in the upper half, and this is minus 2, so in the negative side of the real axis. So this is lying on here, right? This is lying on here. Which quadrant is this? This is second quadrant, right? This is second quadrant. So this is second quadrant. So like now what is the angle for this one? I hope you remember, right, the angle formula for this one. So I don't have a 0, so due to 0 I have 0 contribution. Due to this I got my contribution, and due to this pole, okay, tell me what will be the angle. So basically the angle, right, if you remember it correctly, it was 180 degrees minus theta. Theta was tan inverse mod of y upon magnitude of y upon magnitude of x, or you can say, sorry, mod of y upon mod of x. Basically the absolute value of y upon absolute value of x. So it will be 180 minus tan inverse mod of y upon mod of x, which is like omega upon 2, right? So y is 2, omega, and this is 2. Okay, so this is equals to tan inverse omega by 2. So I hope you get the point, like how does this come up, right? Like we are calculating total 180 over here, and I'm just subtracting the extra theta over here so that I can get the overall angle from the positive real axis to this point. So I'll not explain this further, explain it multiple times, right? So yeah, this is the angle formula basically. Now what do I see? I see plus, right? Even though I have a pole, right? Even though I have a pole, okay, even though I have a pole, right? I don't have any zeros, but still it is contributing positive angle. So what does this mean? This means like something is wrong, something is wrong, right? So basically what is wrong? It is like a non-minimum phase system. Okay, so yeah, let's write down the table, and from there we can understand, right? Yeah, this is a table basically. So I have taken extra pages, is it? I don't know. Okay, let's see. So let's find the magnitude for omega equals to 0. For omega equals 0, obviously we have, it's a type 2 system, right? Like not type 0, so hence obviously our magnitude will always be infinity. Magnitude will always be infinity. Okay, and what about my angle? What about my angle? So angle, right? Angle is 0 obviously, because my angle formula is tan inverse like omega by 2. So let me delete these two pages. So yeah, angle is obviously 0. So what is like the magnitude at omega equals to 1? So at omega equals to 1, if I put omega equals to 1, this is 10 divided by like 1 plus 4, which is under root 5. So it is basically under root 5, 2 times under root 5, right? Okay, or like yeah, this is this one. So let me just calculate this one, then I will check, right? Let me just calculate this one. So do I have the phone? Where did my phone go? Yeah, I have the phone. So like 5 under root into 10, so it is 4.47 basically. So it is 4.47 on, obviously at infinite magnitude, right? It is 0. Okay, so yeah, this is this one. Now what is the angle at under root 5? What is the angle at under root 5? So the angle no, sorry, what is the angle at 1? It is sin plus 1 by 2. So it is like, I think you remember, right? I told you to remember, it is 26.56 degrees, and like at infinity obviously it is 98, because tan inverse infinity is 98 only. Okay, so this is like the polar plot, and what I am seeing is this is going in the positive direction, right? Positive direction. Okay, direction due to pole, due to what? Due to right hand side pole, right? Due to right hand side pole. Okay, this is very important. If I had a pole in the left hand side, right, then obviously it would go in the negative direction, but now as I have a pole on the right hand side, it will go in the positive direction. So it is very important to note that, right? So like from here also, because I have only one pole, right, so I can mark it like this one also. Okay, so this is this one. So like how will my polar plot look? So from where is it starting? So it is starting, right, it is starting from 0 degree axis itself. So it will start from somewhere either here or either here, but will it start from here? For it, like I'm going in the positive direction, so I'll go in the anti-clockwise direction. So for it to start from here, right, I have to cross the 0 degree axis again, the positive axis again. So am I crossing it again? So if I see from here, right, I'm not never crossing my 0 degree axis again. Just initially I was at 0, and it is increasing ever since. Okay, so obviously I will start from somewhere here, right? If I start from somewhere here, then it will increase ever since, and it will go and end towards 90. Okay, and the magnitude will keep on reducing. So like my plot will be something like this. So let me bring this downwards. Let me bring this upwards here. So this is like my polar plot, right? So this is like my polar plot, and like this is at omega 0 and this is at omega to infinity, and like I'm going like this, my magnitude is keeping on reducing. Okay, this similar shape, but just I'm going in this positive direction. Okay, so yeah, this is the polar plot for this transfer function. Now let's go to the next transfer function. So nothing new is here, right? Just like instead of a like in the rotating in the clockwise direction, I'm rotating in the anti-clockwise. Like instead of going in the positive direction, I'm going in the negative direction. Okay, that is just the difference. So what I want you to do is take the second question and solve it for yourself if you haven't already, right? So again, right, I have a pole at s equals to 1. So again, right, let's replace this one with s equals to j omega. So g of j omega h of j omega plus 1. So again, right, the magnitude will be same. So magnitude doesn't change, it's the phase change. And due to the phase change, obviously the direction changes. So if it was negative here, right, if it was like normal pole was in the negative axis, I mean on the left hand side of the s plane, then my plot would be something like this. Okay, so it just became a mirror image. So phase just reverses. Okay, if like the pole from left hand side, it goes to right hand side. Okay, pole just reverses. The phase reverses. In border port also we'll understand this better. Okay, so yeah, this is for this one, right? Now let me write the magnitude function. So this is omega square plus 9. Okay, I will put this over whole under root, right? So what happens is that these two cancel out, right? These two cancel out because the magnitude is same. But in phase, what will happen? These two will become twice. Okay, I will explain you. But for now, like obviously you will see omega square plus in the numerator and omega square plus 1 in the denominator. So obviously these two will cancel out, and I will be only left with 1 by omega square by 9. Okay. So yeah, this is this one. So now what's about the uh, angle basically? What is about the angle? So the angle, right? Let me take a different color. G of j omega h of j omega. Angle is basically, so initially, right, like I don't like, this is a type 0 system. So like I don't have a pole at 0. Okay, pole at s equals to 0. So I will write the contribution for my 0 and then I will write my contribution for my poles. So due to zeros, obviously I will get positive contribution because this is on the left hand side of my s plane, right? 0 is on the left hand side of my s plane. So some positive angle contributed, which is tan inverse omega by 1, which is tan inverse omega itself. Okay, then some negative angle contributed. Okay, so due to this pole, right, due to this one is tan inverse omega by 3. Okay, where did I go? Tan inverse. Okay, and some like again negative angle due to this. But what is the difference here? Which quadrant is this lying? This is lying on the, this is lying on the what, second quadrant? No, again you're wrong, right? This is lying on what quadrant? So let's draw the coordinate axis. Okay, not here, let me draw it here. If you can see that this is lying on the negative real axis, right? Sorry, negative imaginary axis. So in the bottom half of my like this coordinate axis and on the right hand side. So obviously this is lying on the fourth quadrant, right? Fourth quadrant. This is lying on the fourth quadrant. Okay, so basically minus of, so in fourth quadrant what is the angle? It is minus tan inverse theta, right? Minus of minus theta, so it becomes minus of minus tan inverse omega. Okay, this is on the fourth quadrant, right? Okay, this becomes twice, right? Like double. So as I mentioned, right, so this will become 2 tan inverse omega. Okay, and this is angle of g of j omega into h of g omega. Okay, so yeah, this is this one, and obviously I will have the contribution due to left half plane pole tan inverse omega by 3. Okay, obviously the effect due to this one will come initially, right? Due to this one will come initially, then it will be due to this one. So like what you might say is like this is 2 tan inverse omega and this is tan inverse omega by 3, so this is reducing the angle, but not to that extent, right? Not to that extent. So this is much more dominant. So what I can say is like obviously at omega equals 0, what is my angle? My angle is 0. At omega equals to infinity, what is my angle? My angle is 90. And obviously my magnitude is always reducing. My magnitude is always reducing. So I can say that my plot will look something like this. Will look something like this. Start from here and end it here. Okay, just like the previous case. But is it the correct case? No, right? This is not the correct case. Why? Because like it will cut the 90 degrees. Okay, it will cut the 90 degrees at some non-zero magnitude. Why? Because like I have to check like this. Initially obviously the effect due to this one will come, so obviously I will go in the positive direction. That is not an issue. But what is happening is the effect due to this one will also come, so slowly it will reduce the angle also. So what will happen is like obviously you might ask, sir, how do you know this from the start itself that this won't be like this and this will cut the 90 degree axis? So you have to put the conditions, right? What condition you have to put? Like what cases can you put? Can it ever cross the zero real axis? I mean the positive real axis. Can it ever cut the positive real axis? My answer will be no to that. Why? Because initially, right, this is dominating, and this is not dominating for a while, and it becomes way greater than 0. Okay, if this angle becomes way greater than 0, then obviously this negative sign won't come in action, this pole won't come in action, so obviously my angle can't be less than 0. Okay, that is done. Now what else can happen? Like I'm way ahead of 0, so I'm hovering somewhere around here, right? 90 degrees. And what happens? I reach 90 degrees. Okay, I reach 90 degrees, and after that this effect is coming. So how can you check? What you can do, you put omega equals to 1 over here, or you put omega equals to 2 over here. What you will see, like it's something more than 90 degrees, right? It's something more than 90 degrees. So obviously I've written down the threshold points. There you will see that it is crossing the 90 degrees as well, then again it is reducing. Okay, so due to this one, if I draw the pole zero diagram, right, that is why I explained it very well, right, in the previous lecture. So I have a pole at here, then at here, and then a zero. What do I say? I have a pole at here, then a pole at here, and a 0 at here. Okay. So due to this left hand 0, so this is contributing. So my priority will go something like this. Okay, this is contributing positive angle. Okay, and like it will go something like this. My priority will go something like this. It will start from 0 degree axis and it will go here, right? So whichever I'm crossing first, those effects will come first. Okay, so this will contribute positive angle, this will also contribute positive angle. Okay, and this, right, this will contribute negative angle, but at a much later stage, right? at a much later stage. So that's why it will be something like this. So why it won't be like this? So I have drawn the table over here, right? Drawn the table over here, and we have to find. So first let me check whether it will cross the 90-degree axis or not. Okay, so how to check that one? So what you can do is, you have the angle expression, right? So what you do, you put directly this angle equals to 90 and check whether like it will cross the 90-degree axis or not. So you put directly angle equals to 90. So I'll do it a bit fast, right? So, like how to do this in exam might some point come, right? You have to find the point at which it cuts the negative real axis, or you have to find the point at which it cuts the 90-degree angle, right? So all these things, how to find those, I will tell you the process over here, right? So let's say it is 90 degrees. Okay, it is equals to 90 degrees. Now what shortcut I knew was that tan inverse x plus tan inverse y, like tan inverse x, if tan inverse x plus tan inverse 1 by x, then it would be 90. But here I don't have that format, so I have to simply solve it rigorously. So how to solve it? What is 2 tan inverse x? So how can you write 2 tan inverse x? So you can write, so in rough I am doing this, 2 tan inverse x as tan inverse, 2 times omega plus tan inverse omega. And what is the formula for tan inverse a plus b? It is simply tan inverse omega plus omega, that is 2 omega by 1 minus omega square. Okay, so this is the formula. So now this 90 degrees equals to tan inverse 2 omega divided by 1 minus omega square, and I have minus tan inverse omega by 3. So simply what you do is simply put it in the formula, right? Simply put it in the formula. So if you simply put it in the formula, what do we get? So what does 90 degree represent? It represents tan inverse infinity, right? Represents tan inverse infinity. So this is simply tan inverse 2 omega 1 minus omega square minus omega by 3, and again, right, this is the multiple, so this is 2 omega square by 3 into 1 minus omega square. Okay, okay, so this is like this one. So sorry, this will be plus, right? Because like I have a negative formula over here. If it was positive, then this would have been minus. So I would remember the formula. So what do I need to make it infinity, right? What do we need to make it infinity? So what I will do is simply this equals to this, like 1 plus this one should be equal to 0. Then obviously this one will become infinity, right? This one will become infinity. So I don't have space. Let me bring space. So what does this mean? This means something by 0, right? Some finite number by 0 itself. So I will understand that to make this infinity, obviously I have to make this denominator 0. If I make this denominator 0, then obviously it will work. Okay, so 2 omega square 1 plus, not 2 omega, sorry 1 plus 2 omega square by 3 1 minus omega square equals to 0 itself. So omega square 2 by 3 equals to omega square minus 1. So omega square and under 3, okay, which is 1.732 radian per second. Okay, so or how you could have done directly? So directly how you could have done is, so this is the case, right? Here I know like 2 can't be there, else you can't do it directly. But if this is the case, then what we should do, this one equals to 1 over this one. But if you want to do it directly, right, in negative formula, so what you will do, like let me write this one. So if I have tan inverse x minus tan inverse y equals to 90 degree, then x should be equals to minus 1 over y. So this is the direct relation that you can do, right? Okay, you don't have to solve anything, just do x equals to minus 1 over I for this condition to follow, right? For this condition to follow, so you put here 2 omega by 1 minus omega square equals to minus 1 over omega by 3. So then you will get your like this equation directly. Okay, this equation directly, no need to solve further, right? So yeah, that was the shortcut. Okay, if you want to remember it, if you don't want to, don't remember it, no pressure, right? So now we are at omega equals to 0. Okay, now we are at this table basically. So at omega equals to 0, as this is not a type 1 2 system, right? This is a type 0 system. So omega, if I put omega 0 here, what do you see? So it is under root 1 minus 9, sorry, 1 by 9, which is 1 by 3. So it is 0.33, 0.33, right? 0.33. And now what is the angle? What is the angle? So the angle, right? So the angle, like angle, if I put 0, this is 0, this is 0. So this is 0 itself. This is 0 itself. Now, like what is at omega equals to 1? So omega equals to 1, I've already written down, it is 1 by under root 10. So it is, I've written it down, the value 0.316, right? 0.316. Now what is the like angle at like omega equals to 1? So if I put omega equals to 1 over here, so like tan inverse omega 1 by 3 is, try to remember what is tan inverse 1 by 3, right? So all these things you have to remember. So if I, where is it? Yeah, where is it, the formula here, right? So if you put 10, like omega equals to 1, you get 90. Okay, it will be something less than 90, right? 10, like I'm subtracting 10 inverse 1 by 3 also. So what it will be? So it will be almost around something 18.63 something, right? 18.63. So 90 minus 18.63. So like the magnitude, obviously, like I've already written it down, so it is 2.88, right? The magnitude is not that important. So like, sorry, here, right? Sorry, not this one, sorry, I've already written down the magnitude for this one, I'm talking about this one. So it is around 71.360, right? 71.360. I've already written down the plots, right? Just to show you and like right in front of you, I'm doing this. So now what is the magnitude at under root 3? It is something around 0.288. Not important, obviously magnitude will always keep on reducing, not that important, but it will be interesting. At under root 3, if you find the angle, right, what you will get is, you will get 90 degrees. How? So if you put under root 3 here, right, put under root 3, so what is tan inverse under root 3? It is 60. So 2 times 60 is 120, and under root 3 by 3, so it is 1 by under root 3. What is 1 by tan inverse 1 by under root 3? It is 30. So 120 minus 30 is what? 90 degrees, right? So that's why I'm getting 90 degrees. So yeah, I reached my 90 degrees. I'm cutting my 90 degree angle. Okay, that is for sure. And at infinity, what is happening? Infinity again, right? My final angle is 90 degrees. So definitely, obviously, it will come back, right? It will come back. So angle will reduce. Obviously, the effect of pole will come into action right now. So this is 90 degrees. So what is important point to note here is that if my pole would have lied earlier than under root 3, right, then obviously I wouldn't be able to cross my 90 degree angle. Okay, I wouldn't be able to cross my 90 degree angle. Okay, as it is lying, like my pole is lying after this, like at 3, right, omega is 3, obviously, then I will cut the 90 degree angle and then again come back. So yeah, that is the important point to note here is that. So 90 degrees. And like what about at like 10? I've already written down the magnitude. This is 0.57, and this magnitude, right, is 95 degrees. Okay, now what is at infinity? Infinity, it is like magnitude is 0, and this is 90 degrees. So magnitude is 90 degrees. Okay, so like let me write down few things. So these, right, up until this point, like we're having the contribution due to like positive angle due to right hand pole and left hand zero, right? And again, right, this is coming, okay, like not this, up until this point, right? I can say up until this point, like 0 is dominant up until this point. Then after here, what is happening? Like not after here exactly, but the reducing of angle, the reduction angle, I can contribute to negative angle. Okay, so yeah, like how will my plot look like? It will not look like this, okay? Where did it go? It will not look like this. It will look something like this, okay? So obviously add real axis, right? I'm starting with finite this time because I wrote it here also wrong. But obviously, right, it is not infinite magnitude, okay? Not infinite magnitude. So like two things are wrong here. Obviously, it required the 90-degree angle and not infinite magnitude. So we are accustomed to that because we have been solving only type 1-2 systems like this one, right? So like that's why I took a different approach this time. So my magnitude is finite at omega equals to 0, right? It is finite, not infinity. Starting from the real axis, it will go on, cut the 90-degree axis, then magnitude is reducing, and it will end at 90 degrees, right? End at 90 degrees, okay? So yeah, the angle is something like this. So that's why it is going here and not here. So if it ends here, then it is 180 degrees. If it's ending here, right, then it is 90 degrees. Just you have to understand this one. So at this point, right, at this point, my omega is under root 3. Okay, my omega is under 3 at this point. Just key point to note here. So I will not go further into this. So I will directly jump into the next question. So because I don't want to waste much time, right? So what is the next question? Again, right, plot the polar plot, right? Plot the polar plot for like of OLTF with time delay. What does time delay represent? So time delay in time domain, right? So let's say it's my x of t becomes x of t minus tt. So in frequency domain, what does happen? In frequency domain, I get an exponential term, right? Now how to plot the polar plot for those, right? How to plot the polar plot for those? So what you do? You do e raised to power minus s, approximate it as 1 minus s, okay? No, right? You won't do this. Why? Because if you just think carefully, right, what are we varying? Okay, just wait, let me check if it is recording. Just get 10 sometime. So what are we varying, right? So we are varying basically omega, or like s equals to omega, going from 0 to infinity. So when does this approximation is applicable? This is applicable when my omega is really low. But here, is my omega really low? No, right? My omega isn't very low, right? So obviously if I increase my omega to a very high value, obviously I can't do this approximation. So why do we use this approximation? So in root locus you can use this. In Routh-Hurwitz you can use this, right? But in polar plot it is not recommended to use this, right? So polar plot it is not recommended to use this, okay? In polar plot it is not recommended to use this. So yeah, we can't use this approximation. So then what, how to do this? So polar plot is easy, right? We have to plot the angle and the magnitude. So magnitude for this one is 1 only. Like if I put s equals to omega, the magnitude is 1 only. And the angle we'll see, right? Okay. So it is not that difficult to plot the polar plot, right? Here it was difficult, that's why we have to take other options, right? Because always try to take other options when things become difficult. So let me just write the transfer function. Okay, this one. Okay, put s equals to omega. Now, right, again, like first one I will derive what is exponential. I have derived this multiple times, but still I will again derive, right? So let's say I have e to the power I theta, right? e to the power I theta can be broken down into cos theta plus I sin theta, or j sin theta you can say. Okay, so here also I will break down the same, okay, to explain you how does like the magnitude comes like this and the angle comes like this, to explain you once, right? So let me take another pen. This 2 is outside only, this is cos 2 omega plus j sin minus 2 omega, because 2 omega is like minus 2 omega is theta, sorry, I will write here also minus 2 omega. Okay, so cos of minus theta is cos theta itself, so 2 minus, and sine of minus theta is minus sin theta, right? Sine 2 omega. Okay, so this is what this one. So now what if you want to find the magnitude? So if you want to find the magnitude, what will do? You will do cos 2 omega square plus sin 2 omega square under root that. So it is simply 1 itself. So I am only remained with 2, right? Only remained with 2. So simply my magnitude is 2. Is 2, right? Magnitude is 2. Okay, now what about my angle? So if I want to find the angle, so what is the angle for this one? So angle of g omega, right? Simply it is tan inverse y upon x, right? So the imaginary component upon the real component, and as it is in the negative, right? It is in the negative. What will happen? What will happen as it is in the negative? So what I can do is, like, I can replace it like this one also. Okay, replace it like this one also, so that no confusion occurs, right? No confusion occurs. So basically I will write this component only so that you don't get any confusion. Tan inverse, like it is sine of minus 2 omega upon cos of minus 2 omega. Okay, so this one becomes tan inverse equals to minus 2 omega. Okay, so my angle becomes this one. Angle becomes this one. So if my angle is this one, right? So my angle is this one. So like even write this directly. Okay, you can write this directly. So from here the magnitude will be this one and the angle will be this one, right? Okay, so just ignore the j and the angle will be this one. I'll show you in the next question, right? So yeah, you can write this directly without even worrying about that. So I have to derive this one, so I derive this one, right? So this is in the negative angle, so obviously this will rotate in the what, clockwise direction, right? Negative, hence clockwise, because like my omega is positive, right? Omega is greater than 0. Okay, so this is one case, right? So how will this look? So this time, right, first time what is happening, my magnitude is constant. Okay, my magnitude is constant. So my magnitude is constant, it will not go to 0. Okay, and it is rotating the clockwise direction always. So my angle is keep on reducing, right? Like not reducing, it is going to like rotating a full circle 360, then again it is coming back to the circle, right? Okay, because it is keep on reducing to infinity, going towards infinity. From 0 it is going to minus infinity. Okay, so it is rotating, right? So how will my polar plot look? Magnitude is constant, so it will look something like this, right? It will look like a circle, because in a circle the radius is always constant and it is always rotating, right? It is always rotating. It is always rotating. So yeah, this is the case. So it will be like a circle itself. And what is the radius of the circle? the radius of the circle will be 2, right? Because the distance is always 2 constant from the origin itself at all points. The radius is 2. Okay, and angle is like it is rotating in the clockwise direction. That's why I mentioned that, right? It is rotating in the clockwise direction, starting from here, right? Starting from here, and it is rotating in the clockwise direction. Okay, so yeah, this is this one. So now let's go to the the next question. So what is the next question? Next question is this one. This one you try to do it by yourself also. So in this question again, right, I will put S equals to J omega. So it is J omega into J omega plus 2 okay. So yeah, this is this one again, right? What will be the magnitude again? That from here I can directly say the magnitude due to this one, right, will be 1 only. Okay, and the denominator is like what you should compute normally. So the magnitude, so J omega is equals to 1 divided by, like omega will be outside because like again, right, I won't explain further. I've explained these things multiple times. Omega square plus 4, right? Omega square plus 4. So again, I'm going to my same form again, that my angle is always reducing. Sorry, my magnitude is always reducing. So my magnitude is always reducing. Okay, decreasing, or you can say reducing or decreasing function. Okay, it is a decreasing function, right? So, and what about my angle? What about my angle? What about my angle? Angle is basically, so due to this, right, firstly I have a, like it's a type 0 system, so due to this one obviously I will contribute minus 90 degree angles. So that is that I should write this at the start, and then due to the 0, right, what is this contributing? This is contributing minus omega angle. So due to the 0 I'm getting minus omega angle. So we'll not explain this, I have explained this, right, in the previous slide. So, and due to this, what is this contributing? There is a pole, right? There is a pole, so this is contributing minus, like pole will be minus, and tan inverse omega by 2. Okay, tan inverse omega by 2. So yeah, this is this one. So like what I can say, like let me further break this down, right? So this is okay. So this is this one. So 90 minus omega minus 90 minus omega. So what I can see is my angle is also always reducing, right? Always decreasing. Okay. Angle is always decreasing. So like can you plot this one for me? So what I can say is, like it is starting from infinity, okay, from the minus 90 degree angle, then it is always reducing, and it is going in the clockwise direction. Okay, clockwise direction, clockwise, right, because it is reducing. Okay, negative, so it is negative, right, so it is going in the clockwise direction. So like this one it is going. Okay, just like a circle, just like a circle as you saw. So how will it look like? So obviously it will be like a circle itself, right? But this time, right, what will happen? This time, like it is going infinity, because due to this my angle contribution is fixed at omega equals to infinity. My angle contribution is 90, but due to this, right, my angle contribution is always reducing, right? Because this is like, this is not fixed, this is infinite, this can go till infinite, this can't, right? Only at infinity this will max can go to 90, but this has no bound, it can go to infinity. So it will keep on reducing, so like that circle, right? But what is happening in the previous case, right? It was keeping on reducing, right? It was always reducing and rotating in circle, but my magnitude was constant. But here what is happening, my magnitude is decreasing itself, like magnitude is also decreasing. So I will have something like rotating circle, but my magnitude will also keep on decreasing and it will go to 0 some point, right? So how will it look? So it will start from minus 90, right? It will start from minus 90, and will it ever cross the minus 90? Will it ever sorry, I did something wrong, sorry, this is minus 90. So will it ever cross the minus 90 degree again, right? Will it ever cross? I mean, during the initial stages, okay, during omega equals to 0, will it again cross? No, right? Because it's always reducing. There isn't any plus term to help it to cross the minus 90. So from where I will start? From the left hand side or the right hand side of minus 90. I'll start from here, right? This point. So it will be something like this. Okay, we'll start something like this. Let me first draw it, then I will explain it further. Then it will be like a spiral like shape, right? So I will keep on rotating but my magnitude will keep on reducing, right? Magnitude will keep on reducing, okay, and it will end. It can end anywhere. It can end here also. It can end here also. It can end here also. I can't say for sure, okay, because my angle is always reducing. My angle is always reducing. Even at 0 magnitude, my angle is changing. So at 0 magnitude, what can be my angle? My angle can be anything. My angle can be anything, not just 0 degrees. It can't be just 0 degrees. At 0 magnitude, my angle can be anything, right? Anything. So it will always rotate, and it will rotate in the clockwise direction. Okay, so yeah, it rotated in the clockwise direction. So yeah, I think this is like it for the polar plot. So I hope like you got this is the end of this lecture basically. So I've got the point how to plot polar plots for a few unconventional OLTs, right? So these were few unconventional OLTs that I took, right? So first what I took, like in the previous lecture that I took, it was for the, like when I had open loop zeros. So when I have open loop zeros, you have to take care the location of zeros, right, and which are dominant and which are coming to effect first, right? So yeah, that we have to take care of, and where is it cutting, where is it not cutting, like where is effect of zeros coming, where is effect of poles coming. Then even more complex things come, right? Even more complex things come. How? Like this one, right? When I have a like non-minimum phase system. So if I have a non-minimum phase system, then things become difficult. Okay, the angle contribution due to poles and zeros, so the behavior changes, right? So this due to poles it may contribute positive angle, and due to zeros it may contribute negative angle, right? So like, but in the left hand side, if it was minimum phase system, obviously due to poles it was fixed, it will always contribute negative angle, and due to zeros it will always contribute positive angle. This is because that zeros is in the numerator and poles is in the denominator. That's why it is like that. But here things change. Okay, that's why this becomes a bit difficult. So you have to go through the basics. Okay. So yeah, this is this one. Now if I have a time delay, right, then exponential function will come, and how to find the magnitude and the angle for a exponential function I've already told you, right? And like why is this like the 2? Because I have a 2j omega. So if I had, right, like I will just tell you in brief. So if I had 2 of sigma plus j omega, right, then my magnitude won't be just simply this 2. Then what will happen? Just be careful about this one, right? So I will break this down, right, into real and imaginary components. So like this is a power, right? So I can break the power into 2 components, like in multiple application. So this is e to the power j omega. Now the magnitude will be this one, and the angle will be this one, okay, omega. So just be careful about that. If this omega is 0, so what will be my angle? My angle will be what? Nothing. It will be 0, right? It will be 0 degrees, because this is omega is 0, so 0. So I hope you understand it. If I have a real and imaginary component, then you break it down like this one and find the angle, right? Don't get confused by this, right? So my real component is 0, that's why it is not contributing to any magnitude. Just be okay with it, right? So yeah, just wanted to show you that. So yeah, I think this is it for this lecture. In the next lecture again, right, these were few examples, and in the next lecture we will try to solve few gate PYQs and few other questions also, and that through that we will almost wrap up the chapter and we'll start Nyquist plot, right? So yeah, I hope you're liking the concept and all those things. I hope you're preparing your own notes, like you have to prepare your own rough notes also, and you're doing your short notes also, very important, right? So yeah, thank you for watching.